Okay, welcome back to 9-7. Next we're going to talk about absolute value functions. These are kind of fun because no matter what, they will always be this V shape, which is convenient because of the V in value. So there you go. When we graph these, again, we're going to go, I say graph, you say table. And they're always going to have absolute value bars in them. I guess let's just try one. If you recall, I say graph, you say table, when we did quadratics, I always told you, I told you a specific little formula so that you would always know what to put in the center of your table. Same thing today. If you remember quadratics, it was negative b over 2a. This time, the formula you're going to use is actually the stuff that's inside the absolute value bars. So in this case, x minus 4. Set it equal to 0. Solve it. It's usually going to be pretty easy to solve. And that's the number you're going to put in the middle of your table. And then after that, you can just pick a couple numbers that are smaller, a couple numbers that are bigger, and let's plug it in. Remember with absolute value bars, drop the bars, drop the negative. So I have, I'm going to kind of show my work a little low down here. Absolute value of 2 minus 4. 2 minus 4 is negative 2. Drop the bars, drop the negative, that would be 2. So 2, 2. Next up is 3 minus 4, which is negative 1. Drop the bars, drop the negative, that's 1. Oops, I'm not sure why I went to negative 2 there. Let's try that again. So 2, 2, 3, 1. Next up is 4 minus 4. 4 minus 4 is 0. Drop the bars, drop the negative. That's just 0. It looks like I wrote LOL there. Next up is 5. 5 minus 4 is 1. Drop the bars, drop the negative. It's just 1. And last but not least, 6 minus 4 is 2. Oops, those are supposed to be bars. And the absolute value of 2 is just 2. Right there, give or take. If you notice, your table does something pretty special there, and that is it mirrors. And as long as you've done your math correctly, that should always happen. Just like on quadratics where your table mirrored, same thing is going to happen here. So, and then when you plot that, you get a nice happy V shape. So that's really all you have to do there. I do want to clarify, your graph could put, if it had like a negative sign on the outside of those bars, your graph might go upside down like that. It can be skinnier like that, or it can be a big fat one like this. Notice that I'm drawing these pretty much anywhere I feel like on here. They can be in the top half, the bottom half, the left, the right, facing any direction. They pretty much get to do whatever they want as long as they open up or down. So that is all on those. It does want us to state the domain and range. Remember, domain is how far left and right it goes. And even though like it's going to get pretty tall, it is going to go on forever left and right. So the domain is going to be all reals. The range, if it opens up, you're going to use a greater than or equal to sign. If it goes down, it's going to be a less than or equal to sign. So it is y is, opens up, greater than or equal to, and it's going to be the y of the vertex. Wait a minute, we haven't used the word vertex yet today, but we used it back with quadratics. Remember, the vertex is the point where the graph turns around. So the vertex in this case would be this point. And again, if you set your table up correctly, it should be the middle point on your graph. The y of the vertex is 0. And if I look over here, yeah, it does look like it's bigger than 0. All right, next up we'll do piecewise.